In this video, we are going to create another new function from scratch. So we're going to start from a totally blank Matlab script and create a new function. Now, unlike some of the other functions that we've created in this course where, these are not particularly useful functions that you would actually employ in practice, this function in this video is going to be, I think, a useful function. It is pretty likely that you will use the function we are going to create in this video in your future using Matlab. Okay, and so what are we going to do in this function? We are going to count all of the unique elements in a vector or a matrix and return both the unique elements and also the frequencies with which those elements occur. So let me illustrate to you the problem that we are trying to solve. So here is some vector v. I just made up this vector. It is 1, 1, 2, 3, 3, 3, 3. So there's 2 1s, 1, 2, and 4 3s. Now there is a Matlab function called unique. And when you use this function unique, you can input a vector and Matlab will return all of the unique values. So the output of unique is 1, 2, 3, and that's because this vector contains 1s, 2s, and 3s. Now that's fine, and the unique function is pretty useful, but what if we want to know the number of times that each unique element appears? So I want something that's going to tell me that the number 1 appears twice, the number 2 appears once, and the number 3 appears 4 times. Now, functionality like that is not built into the unique function, at least not as of this writing. Possibly future versions of Matlab may or may not have that kind of option. So what we are going to do is create a new function that will return a table of the unique elements like this and also the frequencies of those elements. Now, a terrible idea, the wrong way to go about doing this is to modify the Matlab function unique. You can see this is actually a really, really long function. It's like 300 and 400 lines of code. Okay, so modifying this function is a terrible idea. That's not the right way to do it. Instead, what we want to do is create a new function with a different name that's going to achieve the result that we want. So how do we get started with writing a new script? Do we start writing code immediately? No, we absolutely do not start writing code immediately. Instead, we start by writing high-level comments. So here we have the function call, and let's call this unique. I'm going to call this unique fx. So the unique because it's based on the unique function, and I'm going to call it f because I'm also going to get frequencies, and x because, I don't know, x is just some totally randomly selected letter that I happen to be fond of. Okay, so now the first thing we need to do, or not the first thing, but at the top of this function file is going to be the help file or the help text, and then we need to do some input checks. I'm going to put that in a separate cell. So input checks, and then we need to do, I think the entire function can basically go into one cell. So this is going to be the main function. And then I'm also going to write a few comments in here. So we want to first extract the unique elements, and then we want to find the frequencies, or you might call it occurrences if you like. And yeah, I think that's basically it. I think we're going to add a little bit more to this, but this is good. Okay, so now we have the high-level organization. There's 3 main parts to this function file. Okay, and let's see, maybe I'll also add a few lines of code here, so or comments. We want to make sure, make sure it is, make sure input is numeric. So in theory, you can also do check for unique elements of strings or character arrays. But for now, to make this code a little bit simpler, I'm going to leave it fixed to accepting only numeric input. And then we also need to figure out what happens if the input is a matrix. So I want to make this code work for a matrix and for a vector. I'm going to talk more about this a little bit later on. Okay, so this file is called untitled star. So let's save this. I'm going to set it to the default file name, which is uniquefx. Okay, so now let's get started. I'm going to finish writing this function line up here. So the output is going to be some matrix. I'll just call this UFVals for unique elements and the frequencies. And the input is going to be X. That's what I'm going to call the input. So let's see. We want to start with a line that tells us a little bit about the function. So this is let's see, unique f x x, and then this returns a table with unique elements and their counts or their frequencies or occurrences. Okay, let's see. So we have the input is going to be let's see. So the input is basically just x, and x is a numeric vector or matrix. Now the idea is that I want someone, so if someone inputs a matrix, I want to treat all of those elements as basically a vector, as a collection of numbers. I don't want to have to worry about finding the unique elements for each row or each column. So I'm going to write that the matrices are vectorized. Okay, and then we have the output, and the output is going to be this matrix, this table, UFVals. And let's see, I want these hyphens to line up here. So UFVals is going to be an n by 2 matrix with unique values and their frequencies. All right, so now we have this, and actually, I'm going to add something else here. I'm going to add example, and I'm actually going to add this example later on once we finish the code, but this is going to remind me. So like some functions show you an example at the bottom of the help file, and I want to add that here. I want users to be able to look at this help message and see an example of how to run the function and what the output is going to look like. But we will get back to that later. Okay, and I'm going to delete this. All right, so now for the main function. I'm going to start with the main function. Again, I like to write my functions assuming for the, when I first write it, assuming that all users will definitely provide inputs that I am expecting. So we start by extracting the unique elements. I'm going to call this variable u. So u equals unique x, and that's basically all we need to do. Let me define x so we have something to work with. So I already defined v. I'll just set that to be x. So we have u equals unique x. So now u is 1, 2, 3. Okay, so then what we need to do is build up the output matrix and find the frequency. So the output matrix is called UFVals. Is that what I get? Yeah, UFVals. So I'm going to initialize this. This is going to be zeros. And remember, the output is going to be an n by 2 table. So the n is the length of u. That's the number of unique elements. And then we have 2. Okay, and so now what I'm going to do is loop through all of the elements in here. So for ui equals 1 to length u. By the way, I forgot to mention this explicitly when I started the video, but if at any time during this video you feel inspired to continue coding, you feel like you can go one step ahead of me, then please pause the video and write some code before I get to it. Okay, including right now, this would be a great time for you to pause the video and finish this loop that I'm about to start writing. Okay, so I'm going to say UFVals, and we want the uith row and the first column to contain the unique element here. And then the next one is, now what do we want here? We want to know how many elements in X are equal to this particular element of U. So to do that, we can say X equals U UI. Oops, I haven't, let me run this little bit of code here. So this is going to give us a Boolean, a logical vector that says true, true, false, 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 false. Okay, so these two are true because the first two elements in X are 1, which is the same as the first element in U. Now, we don't actually care about this vector per se. What we care about is the number of ones, the number of trues in this vector. So therefore, I'm going to write the sum of this. And that tells me that the answer is 2. So now let's see, I'll copy and paste that here. And let's try running through this code here and see what it looks like. So we get UF vals. And here we have 1, 2, 3. These are the unique values. And here we have in the second column 2, 1, 4. And these correspond to the frequencies. So the number 1 appears twice, the number 2 appears once, and the number 3 appears 4 times. All right, so that is pretty handy, and that almost finishes this function. So that's kind of the end of this main function. I want to add another optional functionality in a moment, but before that, I want to write down some of these input checks. So we need to check whether the input is numeric, and you already know how to do this from previous videos. I'm going to say if not is numeric x, then we want to print out the help file, so help unique fx, and then I want to say error. The error message is that the input must be numeric. Must contain all numbers. Yeah, that's a bit better. All right, so I'm going to save this file, and now I'm going to start testing it a bit. So let's see. I'm going to say unique fx. Now notice I pressed tab here, so that tells me that Matlab already recognizes this function file. So unique fx, and let's just do, I don't know, something like this. And okay, that's probably good. Okay, so now we get an output. It tells us that the number 3 appeared once. Okay, there we go. The number 4 appeared twice. There's the 2 4s. 5 was once. 6 appeared 5 times, so 1, 2, 3, 4, 5, and 66, this was actually a typo on my part. I meant to hit a space there, so there you go. Okay, so that was a positive case. Now I want to add a failure case. Let's see, I'm just going to add a string in here. All right, and we get the help message, and we get an error message. Input must contain all numbers. Okay, so now the idea of running this as or accepting matrix input is I want the function to return all of the unique values and their frequencies of the entire matrix, regardless of whether it's a row or column. So let's see. I'm going to start by creating a matrix. Let's call it X, capital X, and let's make it 1, 1, 1, 1, 1, 2, 2, 1. And maybe I'll just stop it like this. So here is our matrix. So 3 1s, so 4 1s, and 2 2s in total. Okay, and now I'm going to use not my function, unique fx, but just the Matlab built-in unique function, and let's see what that returns. Okay, so that's good. So Matlab still tells us what we want to know, which is that all the unique elements in this matrix are 1 and 2. However, the question is whether that is still going to work with the way that we wrote this code here. So let's try this. I'm going to say, actually, I'll just say lowercase x equals uppercase x. So then we can do this. We still get u. And let's see what happens if I run this on matrix input. Aha, so here we say, Matlab gives us an error message, unable to perform assignment because the size of the left side is 1 by 1 and the size of the right side is 1 by 3. Okay, so look what I did here. I selected 1, 2, 3, 4, 5 lines of code, and I got an error message. So at least one line of code is producing an error message, but I don't actually know which line of code it is. So the first thing we need to do is actually figure out where this error message is even coming from. I'm going to talk more about these kinds of strategies for finding errors in your code in the next section of the course. But for now, what we're going to do is just run each line of code run this code one line at a time so we can find exactly where the error message is coming from. All right, so it's coming from here. So let's see what's happening here. We have this matrix X and we say equals equals U and the first element of U. Now that actually returns a matrix the same size as the original matrix. And then when we sum over this, the sum function actually works column-wise. So we get 1, 1, 2, and that's because this sum is 1, this sum is 1, and this sum is 2. Okay, so with that in mind, what we want to do with a matrix that gets inputted is vectorize that matrix. Now I've already introduced the concept of vectorizing, so just to give you a quick reminder, if you type a matrix, so this is the matrix, and then in parentheses a single colon, MATLAB will convert that matrix into a single vector like this. So I'm going to do that here. So if the input is a matrix, and actually I'm going to say if not is vector x, then we can say x equals x vectorized. Now, you might think that we don't even need to have this if statement here, because if the vector is, if the input is already a vector, then this does nothing. In theory, this could do something. If you input a row vector, this will convert it into a column vector, but that doesn't change the behavior of the rest of our function. However, I would like to give the user a warning. Not an error message, because this isn't actually an error, just a warning. So I'm going to use the function warning, and the warning is going to say vectorizing the matrix input. All right. So now I'm going to run this function again. Unique fx, let's see, unique fx, and then I'm going to input x. And now we see, so we get the result. We have, let me show you what x is again. So we have the number 1 appears 4 times, the number 2 appears twice, and we get not an error message, the code still ran fine. We get a warning message that tells us that we are vectorized, that the function is vectorizing the matrix input. So this is really useful because maybe I didn't realize that that this was a matrix. So this is a nice way to alert the user to something that it's possible that they are not expecting. Okay, so now I want to go back and run unique f like this. So let's see. Now this is fine. What I would like to do is be able to sort. So right now this comes out sorted according to the first column, which is the unique elements. Maybe we also want to be able to sort this outcome, this output table, according to the frequency. So maybe we want the low frequency numbers in the beginning in the first couple rows, and then the later rows will have the more common inputs, the more common elements. So then this could be 3, 5, 4, 6. Now that is not yet built in here. And in fact, that should be an option. We don't always want to sort. We want to give the user the possibility to request a sorted output, a frequency sorted output. Now in a previous video, I showed you how to use the var argin option here. Var argin, or variable arguments into the function, is useful for optional inputs. In this case, we require this first input. It doesn't make any sense to run this function without one input. So I'm going to write x comma var argin. Now this is going to tell MATLAB that the first input is necessary and any other input is optional. Okay, and then I also need to change this here. I'm going to do this with a square bracket. So I'm going to say like this, sort, let's call this sort f. So return a table with unique elements. So input, then we need another input here. So that is sort f, and that is this is going to be a Boolean, optional sort by frequency, and the default is false. Okay, so that's good. So now we need to fix the input checks to make sure that we are extracting that information out of this var arg in. So let's see. And again, if you feel like you can figure this out before I do, then please pause the video and go for it. So this is going to be optional, or let's say figure out whether to, let's call it determine. That sounds more programmy. Determine whether to sort by frequency. Now I'm going to use the keyword again, n_arg_in. So if n_arg_in equals 1, then we want, well, we don't have a variable yet for this. This is going to be a Boolean. Let's call it sort by frequency. And we're going to set that to false, right? Because n_arg_in equals 1. If this is true, then that means that the user only inputted the vector or matrix and not an optional additional input. So then we want the default value. Otherwise, else, then we want sort by frec to be var arg in, and it's going to be the first element of var arg in here. Okay, and then what do we do with this variable? Well, this is going to need to go down here. Let's see, so this is going to say optional sort by frequency. So I want to write if sort by freq, then what do we do? Well, we have this matrix UF val. Actually, at this point, I think it's a good idea for me to step into this function right here so I can see what n_arg_in and var arg_in are equal to. So let's call the function, and I'm going to give an optional input of true. And let's go up here and check all this. So we have var arg_in is a 1-element cell array, and it's 1 or true. And n_arg_in is equal to 2 because we provided 2 inputs into this function. And now it's interesting to compare the difference between n_arg_in, which is 2, and var arg_in, which is actually only 1 element long. It's a 1-cell element. And that's because there are 2 inputs, but one of them is this necessary input that's called x, and the other one is the variable number of optional inputs. Okay, so here we have our table, but it's not sorted the way that we want. It's sorted along the first column, but we want it to be sorted along the second column. So how can we do this? Well, there's a couple of ways. You already know the function sort. It turns out that there's a related function. In fact, let's even look at the help file for sort. So here is sort. So we could solve this problem using sort, but it would take a little bit longer. Instead, we look at the bottom of the help file. It says C also is sorted, so that's not going to be what we want. Min max, min k, and max k, and so on. Here is actually the key function that I am looking for, sort rows. So let's open up this function. This says sort rows of the matrix. Sort rows of the matrix in ascending order as a group. This is exactly what we want. We want to specify a particular column and then sort all of the rows of the matrix according to that column. So this is unsorted, and now watch what happens when I write sort rows UF vals, and I'm going to give a second input of 2 because I want to sort according to the second column. So here you go. Now the second column is 1, 1, 2, 6, and the first column is 3, 5, 4, 6. So this is now keeping the rows preserved. So 3 was 1, 5 was 1, and 4 was 2, and 6 was 6. All right, very good. So, and that is actually the solution here. So we want to say UF vals equals sort rows UF vals by 2. And, so this is sorting ascending. If you want it sorted descending, you can check out the help file for this function, and you can see how to basically flip this around so it sorts descending. Very nice. So this video went on a little bit longer than I initially anticipated, but that's okay. We covered a lot of really great concepts. We got more experience. Oh, the example. Sorry, I can't finish yet. I need to put in the example here. So I'm going to do, let's see, db quit. Now this video is going to go on a little bit longer, maybe just another minute or so. So let's see, this function is unique f, and let's make this just a little bit shorter. So let's do 1, 1, 3, 3, 3, 3, and 4, 4, 4. How about that? Maybe I'll make this 7, 7, 7, 7. Oops, I didn't mean to keep that in. This is actually interesting. I can also show you if you are already stepped into a function and you want to continue running that function, you can go to Editor and Continue, which is also the same as pressing F5 on your keyboard. Okay, so, oh yeah, but now it has all this stuff. So let me run this again. Okay, so I'm actually literally going to copy this code and paste it up here. So we have our example, and then this just needs to be commented, and I'm going to put some spaces in here. Oops, not there. Spaces here. There you go. And maybe I'll remove that space. Okay, so this shows the example for people to put in 2 carets. So it looks like we are writing Matlab code here. And maybe I'll get rid of that. Okay, so this is what it would look like if someone is running all of this code on their own. They get to type in this example and see this output. Okay, so we covered a lot of material. If you really want to use this function in practice, then I recommend having a good hard think about whether you have all the proper input checks in here, and in case there's anything else you would like to add to the main function.